Pues buenos días a todas y todos. De nuevo, pues estamos aquí en este taller de paleodemografía. Les agradecemos nuevamente que nos acompañen para la segunda parte de este tema que es tan interesante respecto a cómo estudiar, ¿no? Un ejemplo de cómo estudiar una epidemia a partir no solamente de los restos humanos, sino también de las fuentes históricas. Y bueno, para no quitarles más tiempo, le cedo la palabra a la doctora Luana. Luana. So.
Hi, good morning to everybody. So I will start sharing my screen. Okay, I will put in the presentation mode. Okay, so you are, is it okay for you?
Yes.
Yes.
Okay, so let's start. Today I'm prepared to talk to you about the collection representativity, the sample characteristics, my analysis of the stress markers and the stature, and also tools to do intersectional analysis in bioarchaeology. As I said last week, I first, when I organized the presentation, I added the prevalence of stress markers considering the probable age at death. But after seeing, preparing the presentation for today, I saw that it would be too long. And it's a topic that I think we can talk another hour about that. So I eliminated this part. And maybe in the future, we can talk about that. But also, if anybody is interested, there is a chapter in my thesis about that. So let's start. First, I put some points from last week so we can remember and continue. And also, I'm sorry, I'm a little bit sick. So the population that I studied, actually the city, they faced many crises before the plague epidemic when they died. It was mainly wars and extreme climatic events. That was the expression that I was looking for last week and I forgot. I also talked about the representativity based on historical data concerning sex and age classes, also the geographic origin, and the social professional classes that we could verify for the male professions that the plague victims represents the professional categories before the plague. But there is two possible bias in this analysis. The first of them is that we don't know the female professional activity, and also the poor, they are not mentioned among the plague victims. So we don't know how this class was affected by the plague, if it's proportional to the poor of the city or not. And also I presented the archaeological context. This cemetery, it was occupied only during the epidemic, and it was biochemical analysis that proved that the death by plague was performed. And somebody asked me, I think it was in YouTube, how many skeletons were tested. Here in this table, you will find the list of the skeletons that was tested. The first two of them is not from this site, but the others, you can see the list, the result, and the type of the test. This table, it's from the thesis of 1720's from 2009 in the page 109. And here in you have the articles that presented this specific analysis. So if the person is here, he or she can look for it with more details. Concerning my osteological analysis, my sample, to analyze the sex, to identify the sex, I applied the method developed by Buikstra and Jubelaker using the skull and the coxal bone. For the age, I applied the method from the handbook of Paleodemography from Isabelle Segui and Luc Boucher, that is based on cranial sutures, and I used it to see the probable distribution of the skeletons in age classes. And also, we adapted this method to do the probable individual age. I will not present here the probable individual age, but it's described in my thesis. For the adults, I also employed another method based on the public synthesis, the ribs, and the vertebral column. And for the imatures, for the age estimation, I considered Buikstra and Jubelaker again. So my sample are divided in 50 female, 48 male, and 83 imatures. I did not consider here the people with undetermined sex, but I took then consideration some of the analysis. Here is just to give a picture of my sample. So about the representativity of the sample, I will show you a poster that I presented in a conference last week that is available online for download. You can use this code or this link. Let me change here. So in this poster, I will put in full screen. So in this poster, I adapted the method, excuse me. So I adapted the method from the handbook of Paleodemography. That is a Bayesian approach to identify the distribution in age classes of the population. And since it's a Bayesian approach, as prior probability, it considers the pre-industrial mortality standard. But since the plague, it's changed the mortality quotient. So this method, not this method, but using this standard as a prior, it's not suitable for plague victims. And here I also employed this method to check the representativity of my skeletons, because we have the plague victims that are a subsample of the population before the plague, and my skeletal sample, they are a subsample from the plague victims. But are they representative? Because even if we had the cemetery that were occupied only during the epidemic, it was not the only cemetery in the city. So we don't know what we will obtain as a result. So that's why I employed, I did this analysis. The sample you already know from Martigues. For this analysis, I considered 38 women and 28 men that I could analyze, estimate the sex, and also analyze the cranial sutures. So I compared actually the two analyses. The first of them, it's the plague epidemic mortality quotient obtained by the historical data. Both of them were obtained by the historical data. And I compared also the pre-industrial mortality standard. That is the classical method presented in the Paleodemography handbook. I'm sorry. And in this method, sorry. So in this method, I'm really sorry.
Don't worry, Luana. Do you want to take a glass of water or something? Okay.
Hi, I'm back. I will try not to speak. I will try to speak. Not. I will speak low, but if you have a problem hearing, you can tell me. So, in this method, my skeleton data, they will correct the prior, the plague quotient, or the pre-industrial mortality standard. Sorry. And then we will have the result. And here I will present you the result. Here in this curve, we have the standard mortality quotient for a pre-industrial society. So as we can see, it's more far away to my results, because here in with the blue square, it's the plague. Actually, yes, it's the plague result, and also the plague mortality quotient. So my data, it's very similar to the plague quotient. So the distribution of my sample in age classes, they are very similar to the distribution of the plague victims among the age and sex. Actually, here I do not present the sex, but for here is the both sex together. But if you consider them separately, it will not change. So this was the first adaptation of the Bayesian inference method to a well-documented plague context. And this Bayesian inference method can be applied to other plague sites using their specific mortality functions that we should obtain by the historical data. If this historical data is not available, it's better to use the Martigues one than the standard one, because the Martigues one will be closer to them than the standard. And we also concluded that our skeleton sample, they are statistically representative of Martigues plague victims, if we consider age and sex in this case. So let's go back to the presentation. And if you want, like I said, if you want to download, you can find the poster online. So now I will present the physiological stress markers that I analyzed. It was 3 classical stress markers: the clipboard battalion and the porotic hyperostosis. Both of them are non-specific stress markers that they manifest as porosities in the case of clipboard battalion in the orbits, and in the case of the porotic hyperostosis in the cranial vault. They were often attributed by anemia, which some author questioned because there are other diseases that can cause this porosity. That's why I employed them as non-specific stress markers. And in my thesis, I analyzed them separately. The another physiological stress markers are the linear enamel hypoplasia. That's also a non-specific stress marker, that register as stress lived since the beginning of the formation of the crown, so around birth, until the end of the formation of the crown, that's around 7 years old. And it's caused by the reduction of the tooth enamel thickness. One moment. So the results of the analysis considering the immature sample was recently published at Bulletin Mémoire de la Société d'Anthropologie de Paris. Here you have the code to access. It's in open access, so you can see the article. And my objectives with this analysis, first of all, is to evaluate if individuals were differently touched by the stress markers according to sex or age, and also to do a comparison with historical data. My sampling, as Lourdes asked me last week, I considered individuals for the cribororbitalia and the porotic hyperostosis that presented at least one observable bone. For the cribororbitalia, one of the orbits and the cranial vault, and one of the bones of the cranial vault for the porotic hyperostosis. Not the temporal bone, just the frontal, parietal, and occipital. And for the linear enamel hypoplasia, I considered individuals who presented at least one observable crown. Observable means, in this case, no pathology, no taphonic marks, and dental wear not higher than 7. And if we consider the scale presented by Molnar. And I analyzed the number of individuals affected. Actually, here I present the analysis considering the number of individuals affected. In the thesis, I did other kind of analysis considering the intensity of the markers also. But in this case, I think it represents well my results, synthesize well. And I also consider the differences between females and males, between adults and males and immatures, sorry, and also the age classes. And to validate these results, I applied the Fisher exact test for county data. So my results for the cribororbitalia, the immatures, half of them were affected, and they were statistically more affected than adults. I saw no difference between females and males, and the age classes of 9 years old, more or less 25 months, and 10 years old, more or less 30 months, were more affected than the other age classes. For the porotic hyperostosis of cranial vault, there was the individuals, the young adults who have the less than 20 years old, half of them were affected, and also the age classes 15 years old, more or less 36 months, and the adults having 20 to 30 years old, they were more than 50% of them were affected, and we also had they were discriminate according to the age classes. We found no differences between adults and immatures, and no difference considering females and males. But if we consider the age class of 20 to 30 years old, more female were affected, and in the age class 40 to 50 years old, more males were affected. And for the linear enamel hypoplasia, we had also a difference between immatures and adults, where adults were more affected, men were more affected than women, and the age classes that were more affected was 10 years old, more or less 30 months, and 15 years old. And also the adults having more than 20 years old, mainly all the adults, almost all the adults. So here is to synthesize everything. The cribororbitalia affected more immatures and the age classes 9 and 10 years old. The porotic hyperostosis affected more the age classes of 15 years old, the adults having less than 20, and the women having 20 to 30 years old, and the males from 40 to 50 years old. The linear enamel hypoplasia affected adults, men, and the age classes 10 years old, 15 years old, and most of the age classes of the adults. And we could do a comparison with the historical data, the crisis that I mentioned last week. The cribororbitalia that affected the age classes 9 and 10 years old, here in yellow. And yes, 9 and 10. We can see that their period of birth is around the Great Winter. That it was an episode, as we see last week, where we had the highest amount of death before the plague. Of course, these people, they survived. They were born in this period and they survived. But I think that the highest quantity of death shows that it was a hard period. And it's important to consider here not the exact birth. That's why I put it at this long period, because the trouble could have influence in different moments, as I will say in a few slides. And yes, and also the parotid hyperostosis affected also the 15 years old here in yellow. And for the adults, it's not easily possible to link to with the historical data. I'm also employing other methods of analysis now. Yes, but here I show mainly the results concerning the images. And for the linear enamel hypoplasia, we must take into consideration not the period of birth, but the period of the tooth development that is here. And as we can see, for example, the age class of 9 years old they are not significantly affected by the linear enamel hypoplasia. It's mainly one of the possibilities is because their tooth formation for most of the individuals took place after the Great Winter that was here. And the age classes of 10 and 15 years old, that they are significantly affected by this marker, the tooth formation of these individuals there were during the Great Winter, and for the 15 years old, it was also during this other episode. And also here in 1716 that we have a very cold winter. So as we can see, these episodes, they maybe caused the high prevalence of stress markers in these age classes. And we observed, like I showed, that birth around the crisis, a link between birth around the crisis and stress, maybe due to the newborn frailty, but also problems caused by the maternal health during the pregnancy and nursing. That's why I said it's important to consider not the exact moment of birth, but there is a bigger period that the trouble can have affected these individuals. And the adults that we could not at least employing this methodology easily linked to the historical data, maybe because of the bone remodeling in the cases of clipboard battalion, parotid hyperostosis. Another possibility is a natural selection, that the individuals who were more frail, they did not survive until the plague, but also can be due to the different methods employed to age estimation. That's why I am expanding this analysis now, and I hope to have some results soon. And now I will present the analysis that I did of the stature. An article that was an article about that was recently accepted. Sorry, by Bulletin Mémoire de la Société d'Anthropologie de Paris. It's not published yet, but we are doing the final corrections, and I imagine that maybe in October it will be available online, and it's an open access by open access. So later, if somebody is interested, they can check if it's available online. The stature, they are used to analyze living conditions in past or contemporary societies, where we can analyze the resources sharing. They also do an identification of vulnerable groups, and also to evaluate the impact of crisis. That's the case that we are interested here. And the study gathers information since the uterine life until the puberty. That's the period that I'm looking for this analysis. And I compare the secular trends in femur length as a proxy for stature in 3 Mediterranean samples from France, to evaluate the impact of different living conditions on the femur length. And also I compared the female-male differences, not the differences in the height of female and male, but the differences in trends. And the samples that I employed is the first one is from Martigues, as you already know, this sample very well. If you listened to my presentation last week and today. The second sample is from Antibes, from the 19th century. And for the Martigues sample, for this analysis, I considered 47 women and 40 men, only individuals that it was possible to estimate the sex. For the Antibes sample, we had 8 women and I cannot see how many male, but I think it's 18 male. And for the Nice sample, oh yes, so Antibes sample, it was 18 male, and for the Nice sample, 31 female and 33 male. You already know the context of the Thematic sample. The Antibes sample, it was this sample was inhumated in the village cemetery, but from 1897 until 1902, there was a transfer of a cemetery. The city decided to change the cemetery, and they asked the families to change their body of their relatives to the new cemetery. But there were some no-claimed bones that stayed in the same place, that dated from the later period of occupation of this cemetery, from 1877 until 1897. And then in 1998, there was archaeological excavation in this place that exhumed these skeletons. They are bad preserved. And during the century, they lived less crisis than the previous one. And the Nice collection from the 20th century is composed of individuals who donated their body to science. And they died around the year of 1998 until the year 2000. And they are from known sex, we know their sex. And some of them have lived during World War II, during their developmental years. And even with the World War I and II, in 20th century France, we saw a much better living conditions than the 2 previous centuries. So here, yes, I present the context of Martigues that you already know. And that in the 19th century, the life expectancy at birth, it increased with some occasional points of decrease that was due to war and epidemics. But even though for most of the periods the life expectancy was higher than the previous century, and the increase continued in the 20th century. Here we can see more clearly the life expectancy of the 20th century. Sorry, the 19th century. And in the 20th century, the living conditions improved, as we can see here. The death during the first year of life, they are decreased. Even if it was affected during the wars, it decreased. And it was after the sanitary transition when we had fewer deaths due to epidemics and childbirth complications or malnutrition, and more deaths from chronic or cardiovascular disease. We had a better access to resources such as drinking water and food, and also we had the development of the medicine like vaccines and antibiotics that we didn't have the previous centuries. So, and considering that, we expected that the stature will increase during the centuries because of the living conditions that increased. And here we are interested in the final height. So it's in the end of the growth process. Even if there is a variation according to age, due to the compression of the spinal column, it's not the phenomenon that we are looking for here to analyze the living conditions. The living conditions, we must consider the highest, the peak of the growth. That's why we employed analyzed the femur bone. And we prefer to analyze the raw data, the femur directly, not to employ an anatomical method to estimate the height, because there were some errors implicit, and also it considers, yes, the impact of the aging and the soft tissue. That's not the phenomenon that we are looking for. And other, the mathematical method that employs some regressions based on the bone's height to infer the person stature. There's also some errors implicit in this method. But using femur height, we can have the raw data, and since we are comparing just 3 osteological collections, we don't need to know the stature. So that's why we consider the femur length. And for the Antibes collection, we also employed the external Wellacker to analyze the sex, and we grouped the female and probable female, male and probable male. And to see if it was possible to do that, we employed the Kruskal-Wallis test. And we consider the average of the right and left sizes, the right and left femur with the average. And we employed the Mann-Whitney-Wilcoxon test. That's a rank test that will analyze the median to see how many times one collection was higher than the other, to do like a pair analysis, pairwise analysis, sorry. So first of all, I tested if we could do a 2-sex division for the Martigues sample, because here we have separately the female and probable female and the male and probable male. And as I applied the Kruskal-Wallis test, I saw that the probable female, they was not statistically different from the male, nor the male and probable male, but the 2 categories of male and the 2 categories of male, they were different from each other. So I understood that I could consider 2 sex in this analysis, and it would be possible that way to compare with the Nice sample, that we have just 2 sexes in this sample. And also we would have a bigger sample. In the case of the Antibes, considering the fewer number of females, we cannot apply this test. That's another reason to regroup a female and probable female, because otherwise we will not have enough individuals even to apply a test of a small sample. And when we look into the box plot, it's very similar to the other, so we don't see a problem in regrouping them together. So the results of the male stature analysis, as expected, the stature increased during with the centuries. So the 20th century sample, it's higher than the others, and no surprise, as expected. But for the female sample, we had a non-significant difference between the sample from the 20th century and 20th century. So the older and the the more recent one, when the living conditions were very different, they do not have a statistically significant difference. And that, for me, it was a very surprising result. And this method is suitable for a small sample, so we should have seen a difference between those two cases. Another result is that the Antibes sample is smaller than the others. We expected something in between, like for the male stature, but it may be due to the small sample size or due to a non-representativeness of the sample from the living female from Antibes. We may have socioeconomic bias because it was the skeletons that were non-claimed, and we have a high proportion of immigrants in the city to work in the domestic, to do domestic work. So for the Antibes sample to be smaller than the others is not something surprising. It's something that we should investigate in the future, maybe add another collection from the 19th century. But the result for the 19 and the result from the 18 from Martigues and Nice not to be statistically different, that is surprising. And now, finally, I will present some tools to perform an intersectional analysis in bioarchaeology. In the context of gender study, we analyze sometimes the difference of men and women. But men and women, they are not uniform categories. That since, like I presented last week, there are multiple factors that may have influenced the living conditions. So not all men and not all women have the same experiences. And to do that, we need an adapted methodological tool to do this kind of analysis that will not consider these pre-established groups. And what I present here, and here you have a link to another poster. Sorry. So here you have the link to another poster that I presented in 2020 about this study. And to do this analysis, I considered the raw data, the stress markers in this case. And then I performed the factorial analysis of mixed data, and then a cluster analysis. And then after that, considering the cluster divisions, the groups formed by this analysis, I employed a test to see if the groups were discriminant according to sex and age. And the advantage of doing that is that we will do the test of the sex and age after. So the division will take into consideration only the living condition information. And it's the same method that I applied in my master's degree to analyze if there were some differences between the diet of men and women. I analyzed it after to see if we could find some difference related to the sex. So I did 2 studies in my thesis. Here I present the one where I consider the adults and the immatures together. As we can see here in this figure, the method divided my sample in 7 groups. And when I tested it to see if there was a discriminant according to age and sex, I saw that the age classes, they are not statistically different a bit if we compare the groups, nor the sex division. But we saw a division when we compared the matures and the immatures. Mainly, I think it's attributed due to the higher presence of cribororbitalia among the immatures. And this analysis, I wanted to expand it and add other variables. So we can try to find more information about this division. And of course, adding more variables, the division will be another, but to see what are relevant to the similarity between the skeletons. Is it the sex? Is it the age? Is it the living conditions? And I think there is more to do here. So now my final remarks. We could link the observed distress and the historical data to the immature sample, where we saw that a birth closer to crisis, the people who were born closer to the crisis presented more stress markers, and may be due to the difficulties in the beginning of the life, because the newborns, they are more sensible, they are more frail, and also can be due to problems during the pregnancy or in the first years of life. There is also a possibility that women in reproductive age were more affected than the others. I think it's something that I want to investigate in the future, to take this into consideration, because even if we saw that the newborns were more affected, not the people who were born during the crisis, and how were the maternal health in this case. I think there's also more to explore here. So in the future perspectives, like I said, I wanted to add to the intersectional analysis new data that can show social position, or yes, like activity markers or dental microwear, for example. And as I said last week, we have a lack of demographic data concerning women. I don't know how we can obtain more data, because for the city, it's I don't think we can, but maybe in another contexts we can see how women were their social division and everything. There is another possibility of analysis in the future. And also concerning the stature for the male, it was traceable changes according to changes in living conditions. But the female stature, we have this surprising result, where comparing the 18th and 20th century, where we had a non-significant changes. This scenario were also observed in other studies. And also it needs to be further investigated, the social and the biological changes. Maybe it's because of gender discrimination, maybe it was some biological factors. And when I started looking for that in the literature, we saw that was a lack of studies and a lack of data also. Because for some historical periods, we do not have as much data concerning the female stature, and then we have as we have for the male stature. And I thank you for your attention. And here you have the codes to see the works that I mentioned in my presentation.
Muchas gracias, doctora Luana Batista. Pues vamos a comenzar con algunas preguntas, comentarios, con la parte de la, digamos, de la discusión. Bueno, vamos a abrir las preguntas aquí en Zoom. Adelante, doctora Lourdes.
Gracias, Geraldine. Thank you very much, Luana, for your presentation. It's a very complete work that you have done, because you have the privilege to have all this historical data and to complete with the skeletal analysis and the demographic approach is really interesting to see how you integrate all this information. And congratulations and thank you for sharing with us. I have one. You obviously you decided to use CRIBA hyperporosis, porotic in the cranium, and the enamel stress markers. What other markers, even that you didn't include it in this study, but that called your attention and you thought like, this is interesting, could be interesting to analyze? You didn't include it. Did you see another marker that you would use for another study or that called your attention?
Actually, this collection, they were in general, they were in a good health condition. I did not quantify, but now what I wanted to add, it's another, how can I say? It's a kind of analysis that give me another type. No, it's not another type. But for what I wanted to see is because since they were all buried in a plague cemetery, from the archaeological context, we cannot obtain social differences data, you know. So I wanted to see, that's the one that I wanted to add now. And one of the possibilities I thought is through the dental microarray analysis. I don't know how I will do that yet, but it's something that I wanted to do to see. Like I said, not health conditions markers, but social markers. That's what I wanted to do now.
Okay, fine.
That's why it caught my attention more than other stress markers, other type of markers.
Okay, I see. Regarding the stature study, if I understood well, you consider also just the length of the femur, correct?
Yes.
And then how you, because we have, I know it is not straightforward to estimate the stature because you have to consider many factors that can interfere. But the proportion of the long bones, how do you work with that? Because if you have a person that is growing properly and then have some crisis and then the growth is interrupted and then the upper part of the body is going to suffer, will be repressed, won't grow properly, and then you have this disproportion of the length of the bones. In general speaking, something very general. But how do you approach that if you have femurs? I know you decided to do that. Did you consider this proportion of the body in your discussion?
I did not. I have thought about considering to do like an analysis taking into consideration other measures or other bones, but the problem is I would eliminate a lot of subjects. I already have a small sample, so if I will see if just the individuals who have more two bones, the femur and I don't know, the tibia, or the femur and the humerus, and then my sample would be too small to do that. That's why in this case I did not thought to go further because of the sample size. To do that, I would need a bigger sample.
Okay. Okay.
That's but I considered maybe during analyzing not just the height, but the other measures of the femur as to see the robusticity. Yes, I don't know if yes. But I didn't do the analysis. I have these measures, but I didn't do this analysis. Is one of the analysis that I thought. I had the measures for the femur and for the humerus, but if I do, I would need to do them separately, the femur and the humerus, because otherwise, if I consider the individuals who have the both bones, my sample would be very, very small.
Okay. Okay. Thank you very much, Luana.
You're welcome.
Luana, I think
Yes.
we have some comments in YouTube. They say congratulations, thanks for this
Thank you.
presentation. And could you please explain what is microwear marks? Because maybe we have some people that they don't know.
In our tooth enamel, we have microscopic marks that it's due to our diet, but also some other activities, people who use teeth in other functions, as I don't know, to work with tissues, for example. These marks, they are, like I said, microscopic in our tooth enamel. And to do this kind of analysis, the microanalysis to see diet, we must consider not the front tooth, because it will be more influenced by these other functions, or also we can pass our tongue, our lips that are moving. But if we see the molars and the premolars, we can analyze diet patterns. With this method, we cannot say, for example, it's not like the isotope analysis that we can say which food group the person eats. But we can identify, if we do like at a population level, we can see diet patterns that are similar or more different, because the markers, they will form differently according, for example, the type of food, the vegetables, the leaves, they have more what is called phytolith. I don't know if it's the correct pronunciation in English, but it's like a very, very small particles of kind of rocks, but really, really small, that are present in the vegetables, that will mark our teeth. So if we are eating something more liquid, we'll have a pattern. If are eating raw food, we'll have another pattern. So we can, in my master, I did an analysis where I could see some differences related to gender differences in diet. And there are other works also from Hooker that he identified differences related to the ethnic group also.
Thanks for the explanation.
Yes.
Pues,
and it's something that I wanted to do in this sample, since we do not information about I don't know, the place of burial. We don't have funerary goods, so I think that this can give me some information about the cultural practice, to which social group they belong, and it will be interesting to compare with the stress markers.
Okay, thanks a lot. Thanks. Creo que, bueno, en general, pues muchas gracias por esta presentación, porque creo que nos has mostrado la forma, digamos, de potencializar, ¿no?, todas las fuentes de información que tenemos cuando hay esta parte histórica, por una parte, y por otra, cuando se hace el análisis osteológico en los restos, no solamente en el contexto de las epidemias, ¿no? También
Yes.
tenemos un par de ejemplos que nos mostraste, por ejemplo, del cementerio de Tip. Y bueno, creo que en ese sentido, esta presentación nos abre la mente, ¿no?, a múltiples
Yes.
posibilidades para el análisis de las poblaciones del pasado. Y bueno, yo solo quiero agradecerte por esta presentación. Tal vez la próxima vez podríamos hablar de esto de las marcas, de las micromarcas, ¿no?
Yes. Yes, thank you very much for the invitation, and yes, I I have also this other study
Yes,
about
yes,
the dental microwear.
yes.
And in my case, I was how can I say, I was lucky because I worked with Isabelle Segui, who is specialized in historical demography. So she already had the data. I did some of the analysis, the comparisons, but there was something that was already done. So I think in most of the cases, it would be good to work in collaboration with the people from the historical demography, because in the period that I did my thesis, I think it was like 5 years. It will not be possible to do, if I needed me to start this, it will not be possible to be done in 5 years. That it's also, that is sometimes the advantage of doing collaboration and multidisciplinary work with other people. I think our research can get richer, and something that it's not possible for one person to do alone, you know, because it's too much work.
Sí, por supuesto, es súper importante señalar
Yes.
eso, ¿no? Que es la colaboración y bueno, independientemente de que los resultados, bueno, de que ya hubiera análisis previos a la parte histórica, la reinterpretación también conllevó a la colaboración, ¿no?
Yes,
So
yes.
also you made your analysis in collaboration with Isabel Seguí and Enrique
Yes,
Cosinos
and
you know.
yes, and some mathematicians,
Yes.
statisticians. So it's I could yes, I was in an accountant, but I could do that because it's not something that anyone can do alone.
Of course. So, wow, Luana, thanks a lot for your presentation. Really, we really appreciate
Thank you
that
for the invitation.
Y bueno, también queremos agradecer a la Coordinación Nacional de Antropología, Juan Carlos, que nos apoyó en estas 2 sesiones. Agradecerles a todos los presentes, a todos los que nos acompañaron en la primera y en la segunda sesión. Y bueno, invitarlos a que estén pendientes porque esperamos para fin de año nuestro segundo taller de la red de Paleodemografía Mexicana. Y bueno, pues muchas gracias a todos, muchas gracias a todas. Y bueno, nos vemos pronto por el mismo canal de YouTube de la Coordinación Nacional de Antropología. Gracias.
Thank you.
Instituto Nacional de Antropología e Historia.
Secretaría de Cultura.